Hello everybody. Continuing our discussion on Newtonian systems, here I put some examples on special cases where you have objects sitting next to surfaces and you want to draw the force. One of the important things is the normal force to the surface is always at the point of contact toward the system, from the surface toward the system, and normal to the surface. So at the point of contact, I draw this by red color, and in this case this is my system. So let's say at the point of contact here, and then normal to the surface toward the system. So this is our reaction force, whereas here at the point of contact, normal to the surface toward the system. This would be our normal force. So this is say N1, this is N2 in this case, and this force, of course, they cancel each other. They have to have a balance with the mass. Therefore, if you draw this in a free diagram, you realize that you need to have a frictional force in this direction to cancel this force. Otherwise, the force of N2 has a component in this horizontal direction and in a vertical direction. If I draw it in a free diagram system, you have N1, you have Ng, then you have N2, and the angle depends on this angle. I call it theta. So this horizontal component is N2 cosine theta, and the vertical one is N2 sine theta. And this shows that this object is not gonna rest. If there is no frictional force here, the object is gonna move in this direction because the N2 pushing it in this way. Unless you have a frictional force in this direction, you can call it Fs, the surface, and this becomes at this direction, cancelling the N2 cosine theta here, and then the N1 and N2 sine cancels Ng, so you could write it Fs is N2 cosine theta, and then N1 plus N2 sine theta has to be Ng. This is the balance for the system. But how about here? There is a ladder sitting next to the wall. In this way, this is wall 1, this is wall 2. So you could say the normal force to the surface here is at the point of contact, normal to the surface toward the system. This becomes N1, and then here is N2, and then you have a weight, and here you could have a frictional force for this surface Fs1, and then here you could have Fs2, and these two forces are opposing each other. Fs2 in this direction, Fs1 is in this direction. And if you draw the free diagram for this system, you could say that this one is Fs1, this one is Ng, you got N2 also, then in this direction you got Fs2 and N1. They have to cancel each other. We can write down N1 equal Fs2 and N2 plus Fs1 is Ng. This becomes the equation for this. How about here? Here you have a ball sitting at the corner. Now the forcing